Hi everyone, today we are looking at Introduction to Vectors. This is the second half of the course and the shorter half, and we should be able to get through it no problem. So we're looking at section 6.1 today, which is an Introduction to Vectors. So you should have seen vectors back starting I think in grade 10 science, and then if you take any physics you would have saw vectors as well. So a vector is a quantity that has a magnitude and a direction. So here are some of the examples. We have 200 kilometers an hour. That is your magnitude, and your direction is north. We have 30 newtons, again, magnitude, direction, down. That would be like the effects of gravity, right? A newton is a measure of force. And then a scalar is a quantity that only has a magnitude. Okay, so we have a scalar and a vector. Example of a scalar, like 100 pounds, 30 centimeters, etc. So we use an arrow to represent a vector in geometric form. Okay, those are called geometric vectors. And we can also use an ordered pair to represent a vector. And this is called a Cartesian vector, okay, which we'll learn about next unit. So the direction that a vector points is given in one of two ways. So one is true bearing or azimuth bearing. It's an angle measured from north in a clockwise direction. So that means north and to the right of north. Quadrant bearing is an angle between 0 and 90 degrees east or west of the north-south axis. So, example, draw a vector to represent each of the following. 100 kilometers an hour at a true bearing of 40 degrees. So, no problem. I will draw our plane first. And then 40 degrees. So we are going to be something like this. And 40 degrees is right there. Okay, so it's 40 degrees north, and this is 100 kilometers per hour. All right. Next one, we have 50 newtons at a quadrant bearing of north 60 degrees west. So again, we'll draw our north-south axis. Okay, and we'll label it north, east, south, and west. So north is where we start, and we're going 60 degrees to the west. So it looks something like that. There we go. Now it's working. Okay, we'll extend that right there. And we have that this is 60 degrees. Okay, good. And last one, 5 kilometers at a bearing of 145 degrees. So again, we'll draw a Cartesian plane. And 145 degrees, so we're going to go 90. Then we'll go another 10 is 100, and then we go another, that's 55 degrees. Okay, so we have 90 there, plus 55 is 145. Okay, so for these ones here, I just have this converting between true bearing and quadrant bearing. Right, so again, easiest way to do this is we just sort of draw a picture. Okay, and we're going to go south 35 degrees east. Again, so we have west, and we're going to go south, and then 35 to the east. That means that this right here is 35. Okay, which means that we're looking at from here to here to get to the true bearing. So it's going to be 180 minus 35, which is, I'll write it down here, I guess, 145 degrees. Okay, good. So those are equivalent. Next one, 265 degrees. So again, we'll draw our axis, and we're going to go here, here, here. So all from here all the way to here is 270. 265 is 5 degrees less. It's not drawn to scale, right? Obviously that's 5 degrees. Okay, and let's see here. Get rid of this. There we go. So we have 5 degrees there. Okay, but we're always going from the north-south axis. We're going to go south, and this is 85. So we're going to go south 85 degrees west. Okay, good. And last one here. Okay, and we're going north 40 degrees to the west. So it's this way here. And that's 40 degrees. Okay, so then our true bearing is, if we go here, that we're going from here all the way to here. So it's going to be 360 minus 40, which is 320 degrees. Okay, perfect. All right, so now some definitions. So parallel vectors, okay, are vectors that have the same or opposite direction. Okay, equivalent vectors have the same magnitude and direction, and opposite vectors have the same magnitude but opposite direction. Okay, so one way you can write it is you can say that if we have a vector like from A to B, okay, and the opposite would be from B to A, and we go like that and write like that. All right. So next one, just a couple questions here. Are equivalent vectors parallel? Yes, they are, because they are the same vector. And are parallel vectors equivalent? Not necessarily. Since they can have different magnitudes. Okay, and last thing for today. Example, given the parallelogram below, state equivalent vectors and opposite vectors. So equivalent, okay, so equivalent, we have vector AD, okay, that's your starting point, your ending point, okay, is equivalent to vector BC. Okay, and like vice versa, you can switch the direction. Okay, we have AB is equal to DC. Okay, good. And opposite vectors, right, as we just switched yours. So we have AD and DA, or AD, so opposite. We have AD and DA, or CB. Okay, I'm not going to state all of them just so you get the idea. And same thing here, we have that AB and CD. Okay, and there is your work for today.